In this section, we want to calculate the design wind pressure for the small door which has 3 square meter area and is located on the northeast wall, which is shown here. For this door, we might have 3 different situations for wind loading. So the first situation would be when we have wind in northeast direction. In this situation, we will have positive pressure on the door. The second situation is when we have wind in southwest direction. In this situation, we will have negative pressure on the door. And the third situation is when we have wind in northwest or southeast. In this situation, we will have negative pressure on the door. So let's look at the first situation, which means positive case, positive pressure, and related to wind load in northeast direction. So in this direction, the design wind speed would be 30 meter per second. KCE and KCI are going to be 0.9 because this is related to the case for when we have internal and external pressures. KL for windward wall is 1. CPE again for windward wall is going to be positive 0.7. And CPI is negative 0.3 or 0. So CFIG and external with these values would be positive 0.63. And our external wind pressure with 30 square meter per second design wind speed, it's going to be positive 0.34 kPa. Now let's look at internal wind pressure. So our CPI, we had 2 values. So we need to look at the negative value, and the reason for that is that the external wind pressure is positive, so it's toward the surface. Internal wind pressure, if it's negative, is going to be away from the surface. So in this case, we can add these 2 values together and get the largest value. So as a result, we are looking at the negative case, and our CFIG would be negative 0.27. And then our internal wind pressure with this CFIG would be negative 0.15. Now, if we add internal wind pressure with the external wind pressure, we can get the net pressure on this door, which is going to be positive 0.49 kPa. The second wind loading situation on our 3 square meter door would be when we have wind in either northwest direction or southeast direction. So we have to see which one is going to be governing, and it's going to give us the maximum external wind pressure. So if we look at northwest direction, design wind speed is 37.4 meter per second. And CPE is going to be negative 0.5. And the reason for that is the door is located in the area that is from 1H to 2H distance from the windward edge. If you look at southeast direction now, our design wind speed would be a little higher, but our CPE is a lot less. And the reason for that is that the door is located in the area that is the spacing would be larger than 3H from windward edge. So if you look at this picture here, so we are looking at the wind in this direction, southeast. So we are looking at this spacing from windward edge. So this is larger than 3H. Now let's look at other parameters that we need to calculate wind pressure. So KL in this case is going to be 1.5, and the reason for that is that the area of the door is 3 square meter, which is larger than 0.25 a to the power of 2, but is less than a to the power of 2. So if we look at table 5.6 from AS 1170.2, so we can see our case is going to fall here, and our KL would be 1.5. So Ka is going to be 1 because the area of the door is 3 square meter and is less than 10 square meter. So from table 5, Ka would be 1. And Cp, as mentioned, is negative 0.5. Kc would be 1 because our internal wind pressure is going to be 0. So we had two values of negative and 0, but because our external wind pressure is negative, in order to get the net pressure, we need to look at this 0 value for internal pressure. So let's calculate Cfig and external with all of these parameters that we already have. So Cfig would be negative 0.75. And as a result, our external wind pressure with design wind speed of 37.4 for northwest direction would be negative 0.63 kPa. Now, combined with the internal wind pressure of 0, our net pressure on the door would be negative 0.63 kPa. And finally, we want to look at the third wind loading situation we might have, which is the wind in southwest direction. So in this situation, we will have, so our door will be on leeward wall. So our CPE would be negative 0.5, which is for the leeward walls. Ka would be 1, again for leeward walls. And our Kc and E is 0.9. This is for doors and windows when we have internal and external pressure. And our KL would be 1. This is the case for leeward walls. So our Cfig would be negative 0.45. Now we can calculate external wind pressure with design wind speed of 42.8 for southwest wind direction and this Cfig that we calculated now and 1 for C dynamic. So the value would be negative 0.49 kPa. Now let's look at our internal wind pressure. So as you might remember, when we were looking at southwest wind direction, because of having a big opening in this direction, we had a positive internal pressure. The value for CPI was 0.9 times CPE, which is 0.7 for windward wall. So the value for CP and I would be positive 0.63. Now, in order to get Cfig and I, we need to times CPI times KCI. KCI is 0.8 because it's an effective surface. So our Cfig and I would be 0.5. Now our internal wind pressure would be positive 0.55 kPa. So now we just need to combine this internal and external wind pressure to get the net pressure on our door. So in order to combine them, we need to know how to combine these loads together. So if we look at the external wind pressure, because it's negative, it's away from the surface. And our internal wind pressure is positive, so it's towards the surface. And as you can see, they are in the same direction. So we can add these two values together to get the net pressure. So the value would be 1.04 kPa. And if you compare this value with the values we had for the two other wind loading cases that we had, this is much higher and it's going to be our governing case for designing the door.